Hi guys, today we are going to be verifying trig identities. So this lesson will be kind of similar to section 3.2. The one advantage though, if you look at this bottom example, 3.2 I just gave you something that like what I just circled. However, 3.5 I'm telling you where I want you to go. Okay, I have a specific end that I need you to achieve. Okay, so that should help a little bit, but some guidelines. These are merely suggestions, okay? They're not set in stone that you have to do this way, but here's some things I want you to think about, okay? First, work one side of the problem at a time. You can work and simplify either side you want. Just work one side as much as you can, then move over to the other side. Granted, I suggest maybe starting with the more complicated side first. Okay. Always be looking for opportunities to factor or adding and subtracting fractions, okay? Now, the advantage to that, factoring or combining fractions, majority of the time, factoring and combining fractions will lead you to an identity, okay? Which brings me to number 3. Use your identities. Okay. Now, when I say that, use your identities, for instance, look at this example. The final answer is sine squared. So the identities I would want to use in manipulating this probably need to have sine in them somewhere because that's where we need to end up at. Okay. If 1 through 3 doesn't help you, all else fails, convert everything into sines and cosines. And then start manipulating. And lastly, and this is distance seated, this is the biggest struggle for many of you. Always try something, okay? You are never going to get an answer if you just look at it and say, nope, don't know what to do. Okay, and I know that sounds really sassy of me, but I promise, you have to try something. If you hit a dead end, that's what erasers were made for. Erase and try something different, okay? So, when I begin working through these, know that there is more than one correct way to go about these. So many different correct ways, okay? All right, so secant squared minus 1 over secant squared. And I want to try and make it match the right side. I want to make it be sine squared. Well, first thing I see the secant squared minus 1. There's an identity that says 1 plus tangent squared equals secant squared. If I manipulate my identity, and if I subtract 1 from both sides, I now have that tangent squared equals secant squared minus 1. So I can replace this piece of the left side of my function with tangent squared. So I'm going to do that first. All right. I at least got rid of the subtraction. That's a good thing because my final expression, sine squared, doesn't have any subtraction in it. All right, so now I need sine, and I don't have any sines. However, there is an identity for tangent that says tangent is equal to sine over cosine. So if I squared this to make tangent squared, that would give me sine squared over cosine squared over secant squared. Okay, well, maybe getting a little bit closer, but I need to get rid of the cosine and the secant, which then I remember, secant is equal to what? Secant is 1 over cosine. So again, if I need squared, what happens when I square that? So now I've got sine squared over cosine squared over 1 over cosine squared. All right. Now, and I'm going to erase this in just a second, this piece, I have a fraction divided by a fraction. We don't do that. Instead, I'm going to come right here. We multiply by the reciprocal. If I multiply straight across, I now have sine squared, cosine squared, over cosine squared. Hey, looky there. Cosine squareds cancel, leaving me with sine squared equal to sine squared. Pretty nifty. Okay, so all this work was not part of the problem. That was just me manipulating identities to find something that I could switch things out with. Okay, I'll work another one on this video, and then second video you can watch to see the other 3 examples. All right, so looking at this one, the left side is far more complicated than the right, so I'm going to start there. And I have addition of fractions, so I'm going to get common denominators. Okay, so I get 1 plus sine alpha over, and I have to distribute. Okay, plus 1 minus sine alpha on the numerator. Okay, now I have my common denominators, so we add straight across the numerator. Keep the denominator, and I hope you all notice that I have a positive and a negative sine alpha in both of those denominators, so I'm going to go ahead and cancel that. But now in my numerator, I also have a positive and a negative sine alpha. Those are going to cancel. Oops, I forgot my equal to. Okay, so now I've got 2 over 1 minus sine squared alpha equal to 2 secant squared alpha. All right, well, I at least got rid of the 2 separate fractions, but now, 1 minus sine squared alpha. I have an identity that says cosine squared plus sine squared equals 1. If I subtract the sine squared from both sides, I have that cosine squared is equal to 1 minus sine squared. So I'm going to plug cosine in right there. So now I have 2 over cosine squared alpha equals 2 secant squared. Oops, that was an alpha and I wrote next. All right. Now I see 2 times 1 over cosine squared. 1 over cosine is equal to secant. So if I square both of those pieces, I would get 1 over cosine squared is equal to secant squared. So I now know that I have 2 times secant squared alpha, which is equal to 2 secant squared alpha. Okay, take a look at the